So this is video 2.1b as in boy, the second video on trig functions and acute angles. So we're going to talk about cofunctions here for just a few minutes, and also again about labeling triangles. Each angle in a triangle is labeled with a capital letter. Each line segment is designated by a lowercase letter. And that line is always opposite of the angle. So here's B, and the line opposite, which has no line in common. See, this one and this one are in common with B, but this line here doesn't have anything to do with it. So it's considered the opposite line. And the opposite is always designated with the same letter, but in lowercase. C is uppercase, C is lowercase. A is uppercase, across from it is lowercase. So angles or triangles are always designated that way. And one of the things I want you to see here is, let's say that we're going to take the sine of A. The sine of A is going to be the opposite over hypotenuse, which is A over C. The cosine of A is going to be adjacent over hypotenuse, and the hypotenuse is C. Now let's look at the sine of B. Sine of B is going to be the opposite of B over the hypotenuse. Whoops. And the cosine of B is going to be adjacent A over hypotenuse. Okay, so given that bit of information, I want you to look at something that is going on here. The sine of A and the cosine of B. So the sine of this angle and the cosine of this angle are the same thing. The cosine of A and the sine of B are going to be the same thing. That means that they're cofunctions. Cofunctions are functions of a triangle where one is equal to the other. So what I can say is the sine of A equals the cosine of, write it there, and I can also say that the cosine of A equals the sine of B. And in fact, I can just go on and on and on about that, but rather than do that, let's look at some of the other ones. Let's look at tangent of A equals the cotangent of B, and and vice versa, and the secant of A equals the cosecant of B. Now, one of the things I'm going to erase all this so we can see our picture here better. One of the things I want you to get here is that A plus B is 90, because C is 90, and you add this up to 180. 180 minus this angle is 90, so this plus this must equal 90. So we can actually say that the sine of A equals the cosine of B. Well, what is the cosine of B? Well, 90 whatever A is. So that's why the book in the blue on cofunction identities has that written that way, because this angle right here is just the other angle, because when you add A and B together you get 90. So A is going to be one angle, this angle is going to be that 90 degrees minus this, and that will give me this one. So that's why we called it 90 minus A, and that's why they did that on in that blue chart there. So for example 2, they say write each function in terms of its cofunction. So the cosine of 52 degrees will be equal to, well, if you look at that chart, it says the cosine of an angle, we'll call it A, equals the sine of 90 degrees minus A. So actually what they're doing is they're saying, okay, I know the cofunction of cosine is sine. And this angle that's going to go right here, the sine of something, is going to be whatever this is from 90. So the difference between that and 90. So this is going to be a 38-degree angle. So if the cosine is 52, the sine is going to be 38. Okay, so that's all you have to know about that is what is the degree here that you have to add to this to get 90. So you can do that with any of them. You can do cosecant of 52. Well, I know that the cofunction of that is secant. So now all I have to do is find an angle that I can add to 52 and get 90. And again, it's 38 degrees. So I don't know if they make it harder than what it really is. It just kind of seems that way. So let's look at B, tangent of 71 degrees. Cofunction of that would be cotangent, and then whatever it takes to get up to 90 degrees. So we add 19 to it. If I have the secant of 24 degrees, the cofunction is going to be cosecant of the difference between 90 and 24, and in this case it's 66 degrees. So this is example 3. It says find one solution for each equation. Assume all angles involved are acute angles. Alright, so we look at this, and we just went over cofunctions, and the cofunction of one angle is the same as cosine of one angle is equal to the sine of one of the other angles. So we're assuming that this is a triangle, and this is our A, and this is our B. And they're saying that they're equal here. So if they're saying that they're equal, that means that I can say that this angle plus 4 degrees is going to be added to this angle plus 2 degrees, and that's going to be a 90-degree angle, because if they're cofunctions, if you take the angle of this one and the angle of this one and add them up, you're going to get 90. You have to. If this were cosine and this were tangent, that wouldn't have to be that wouldn't necessarily be true, but because they're cofunctions, cosine and sine are cofunctions, this plus this is 90. So now we add these up, and remember our theta is just a variable. So theta plus 3 theta is 4 theta, plus 4 plus 2 is 6 equals 90. 4 theta equals 84, and then we can just divide by 4 and get theta equals 21 degrees. Okay? If you look in part B of this one, we've got the tangent of 2 theta minus 18, and we're saying that equals cotangent, which is its cofunction, theta plus 18. Because that's true, we can just say that this plus this equals 90. We solve for theta, we get 30, life is good.